Dividing a decimal by a decimal. First, let's take a moment to close read the problem. Mariana has $2.15. She only has nickels. How many nickels does Mariana have? Model by representing with an equation. Show two other ways to represent this problem. For example, you can use base 10 blocks, money, a number line, or grids. Before we begin, take a moment to retell the situation to a partner. What do we know? What are we trying to find out? What might the equation look like? How could we use math tools to help solve this problem? In order to write an equation, we need to decide how to represent our unknown. Let's let n equal the number of nickels Mariana has, since that's what we're trying to find out. Since Mariana has $2.15 and she only has nickels, we are dividing $2.15 by a group size of 5 cents. In Lesson 1, we knew the total and the number of groups. For problems in Lesson 2 and this lesson, we know the total and the group size. Our question is how many groups of 5 cents are in $2.15. Let's take a look at some strategies that could be used to solve these problems. We know that Mariana has $2.15. Our representation shows $2.15 with $2 bills, a dime, and a nickel. We know that Mariana only has nickels, so we need to trade the dollar bills and the dime for nickels. A dollar has 10 dimes, or groups of 10. If we want to know how many fives in $1, we can think about the fact that it takes 2 nickels for every dime. So it takes double the amount of nickels as compared to dimes to make $1. Since it takes 10 dimes, we know that it takes 20 nickels to make $1. Let's trade our dollars for nickels. We also need to trade the dime for 2 nickels. We have 20 nickels from the first dollar, 20 nickels from the second dollar, and 3 extra nickels. So Mariana has 43 nickels. $2.15 divided by 5 cents equals 43 nickels. This math story can also be represented with base 10 blocks. We can represent the dollars with 2 flats and the 15 cents with a rod and 5 small cubes. Since we are seeing how many 500th size coins fit inside $2.15, we can decompose each block into 500th size pieces. The first dollar is separated into 20 groups of 500ths. With actual base 10 blocks, these may need to be made into groups of 5 small cubes. We can represent the other base 10 block representing a dollar in the same way. Then we can break the rod representing 1/10 or a dime into 2 500th size pieces. We can combine the 500th pieces to make one group of 500ths. Our final equation is just like the equation in the first example. We had 20 plus 20 plus 2 plus 1 is 43 groups of 500ths, so 215 divided by 500ths is 43. Another tool that can be used to solve this problem is decimal grids. This time, each 10 by 10 grid represents $1. So the gray area represents $2.15. We are seeing how many nickels or groups of 500ths are in the gray area. We can use color to highlight the groups. One group of 500ths is blue. Each time another 500ths is shaded, another nickel is included. There are 20 groups of 500ths in the first grid and 20 in the second grid. The third grid has 3 groups of 500ths. So 20 plus 20 plus 3 is 43 groups of 500ths. Again, we can represent this situation with $2.15 divided by 500ths equals 43 nickels. A number line is another helpful tool for solving this problem. Since we are trying to see how many 500ths coins are in $2.15, that's how many nickels are in $2.15, we can repeat a 500th jump until we reach $2.15. We can begin with only 0 on our number line. After we make 1 coin, we are at 5 cents. After a second nickel, we add 5 cents and 5 cents. So we can see we are at 10 cents. Then after a third nickel, we're at 15 cents. We keep adding nickels until we reach $2.15. Notice it took us 20 nickels to reach $1. But we're going to continue until we get to $2.15. Now we're at $2. And finally, after the 43rd jump of 500ths, we're at $2.15. So $2.15 divided by 500ths is equal to 43. Creating this number line with 43 jumps was very tedious. Let's think about how we could use something we already know to help us find the total number of nickels more efficiently. What if we use smaller chunks that we know will help us? Since 10 times 5 is equal to 50, we know that 10 nickels is 50 cents. Let's think of how we could show that on a number line. We can use one jump to represent 10 nickels, and we record what we land on as 50 cents. Then we can jump 10 more nickels, and we're on $1. Since it took me 10 plus 10 nickels to get to $1, I know that 10 plus 10 is 20, so it takes 20 nickels to make $1. So if I go another 20 nickels, I'll land at $2. I know that 3 times 5 is 15 cents. So I can add 15 cents to $2, and I'm at $2.15. We add 10 plus 10 plus 20 plus 3 to see that it took 43 nickels to make $2.15. Instead of making all 43 jumps, we were able to combine jumps using friendly numbers and find the total number of nickels in only 4 jumps. $2.15 divided by 500ths is 43 nickels. Thank you for watching Dividing a Decimal by Decimal.